So section P2. Section P2 is called the Cartesian coordinate system. That just means x comma y. So Cartesian means rectangular. I'm just going to use the midpoint formula and the distance formula from this section. I think that's all I'm doing. Oh, and then on the back, we'll talk about circles. All pretty easy stuff. Forgot about the circle stuff. But it does all go together, and I'll show you why here in a little bit. So the distance formula, before I just write down the distance formula and say, memorize this thing, I don't like having to tell students just memorize some stuff. I like my students to understand why things are true and where things are coming from. The way my memory works is if I can understand why it's true or where it came from, then formulas, they basically just write themselves. They're so much easier to memorize if you know where they come from. Now, I could teach you to say things in German all day long, but that doesn't mean you know what you said, right? If you don't know what you said, you're probably going to forget it. But if I teach you some German statements and then I tell you what you said, it's going to mean a lot more, and you'll probably remember it because you know what it means. Math is a language. I believe that the same principles apply here. So what am I getting at here? I'm getting at something you should have learned in geometry, one of the most important properties you learn in geometry, the Pythagorean theorem. You guys remember the Pythagorean theorem? A squared plus b squared equals c squared. It's the way we find side lengths of right triangles. The distance formula is nothing but a version of the Pythagorean theorem. So if you know a squared plus b squared equals c squared, and you're comfortable with me telling you that c always represents the hypotenuse, and in the image that I'm working with right here is actually represented by the letter d for distance, then you would say, oh, then this is A and this is B. And no, which one is A and which one is B does not matter. That's not important. So the length of this side squared plus the length of this side squared equals the length of this side squared, right? So instead of saying the length of this side, what if instead I said the distance between this x value and this x value? I mean, if this x value is at 1 and this x value is at 5, you could tell me that this thing has a horizontal length of 4, right? Well, all right, it actually doesn't matter what those two x values are. In order to find the length of the side, you would always do one minus the other. Now, our textbook did something that I think is weird, and they said x1 minus x2. Is it wrong? No, it's strange. Normally we do end minus beginning, and end minus beginning is a pretty big deal, and I'll be saying those kinds of words a lot to you. It gets said a lot when I teach my IB students calculus. It's always end minus beginning. It's a pretty important deal. So realize it doesn't matter what order these are in because our textbook used absolute value signs. I like x2 minus x1. So I'm going to write this as x2 minus x1. If that's a, I do have to square it. Plus, and the same principles apply to the vertical side. I mean, if this was at 7 and this was at 10, I think everybody in the room can tell me this had a length of 3. And that's because it's literally just one of the y values minus the other. And you would use absolute value symbols just to make sure you don't ever get a negative distance because there's no such thing as a negative distance. And that's why our authors actually didn't care what order they put the subtraction in because they put the absolute value bars. Again, I think it's odd. It's almost always written as y2 minus y1. So that's the way I'm going to write it. But realize it doesn't matter because if you square a negative number, it turns positive. So the order of the subtraction doesn't matter when you're going to square it. So instead of saying b squared, I'm going to represent it as y2 minus y1 squared. And that would give me the hypotenuse squared. But instead of saying c, I'll use the letter d for distance. So what we've done is we've used the Pythagorean theorem on a right triangle drawn in the x comma y coordinate system. So if you wanted to know the length of the hypotenuse, which, by the way, would actually be the distance between points P and Q, all you have to do is isolate D. That means get rid of the square. And we get rid of squares with square root bars, like so. And there is no such thing as a negative distance. Technically, when you cancel a square with a square root, you are supposed to say plus or minus. But since there's no such thing as negative distances in the real world, we don't need to write the plus or minus. Instead, we can just write the distance formula as distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. You learn the distance formula in algebra 1, and I don't think that they explain to you where it's coming from. I think it's one of those things where they just go, hey, here's the distance formula, use it. Trust us, it's true. I don't know. I need to remember my names, but Alex B, you said you're from England, correct? And from my understanding, they don't teach algebra 1, geometry, algebra 2. You basically just have something like integrated mathematics. Parts of everything, right? And I think that's what they do up north in New York. Anna, you're from New York, right? They just do like integrated 1, 2, and 3 and things like that, right? Yeah. So in those kinds of systems, you wouldn't teach the distance formula until you teach the Pythagorean theorem, because then it's obvious where it comes from, right? And the reason why I ask is because I teach IB, so it's fantastic having someone from another country, because I could talk about international mindedness. Now, this is not an IB class, but it's still interesting to find out. And even though New York's not another country, well, it might as well be, because they're so weird, right, Anna? Yeah. No, it's okay. I can make those kind of jokes. My wife is from New York. All right. So that's the distance formula. That's where it comes from. Know it, love it. So let's find the distance between 2 points. It doesn't matter which one you call x1, y1, which one you call x2, y2. That's not important. Doesn't matter whatsoever. And the reason why is because you are going to square it after you subtract. So no big deal. I'm just going to say the first one's x1, y1, because I feel like that's easy. And the second one's x2, y2. And I'm just going to plug and chug into the distance formula. Distance is square root of parentheses x2 minus x1 quantity squared plus y2 minus y1 quantity squared. 6 minus 1 would be 5. Negative 1 minus 5, that's negative 6. I'm going to be careful when I write this. I'm going to make sure that I keep that negative sign inside the parentheses. If you don't write parentheses, and you could try this on a calculator if you don't believe me, negative 6 squared without the parentheses equals negative 36. That's because you would use the exponent before the negative sign. But if you put that negative sign inside the parentheses, it is bossed around by this exponent. So what we get here is 25 plus 36. Or quick math, 61. Square root of 61. I don't know what that is as decimal. Let's see, 7 squared is 49, 8 squared is 64, so it's a little bit less than 8, 7 and change. That's good enough. Square root 61 is good. That's a prime number, so it doesn't reduce. There it is, square root 61. I'm happy with that answer. Any questions on distance formula? Or is it okay? Not bad, right? Okay. Midpoint formula then. Again, rather than just write the formula, I like my students to know where they come from, because I think that makes it very easy to memorize. Let's say you get an 80 on one test, and then you get 100 on the next test. What would be the quote unquote midpoint between the 80 and the 100? Somebody could shout it out. I'm fine with it. Yeah, 90. So instead of asking the question that way, let me rephrase it. If you got an 80 on one test and 100 on the next test, that number 90 would be known as your test what? Average. See, the midpoint is nothing but the average of two numbers. That's all it is. So you average the x's, you average the y's. How do we average two numbers? Add them up and divide by 2. And that's where the midpoint formula is going to come from. It's going to be the first x plus the second x again. It doesn't matter which one you call the first and which one you call the second. So like I was saying, it doesn't matter which one is first, which one is second. Add them up, divide by 2. And then same thing's going to happen over here with the y values, b and d. So that is the midpoint formula. That's where it comes from. It's just an average of the x's and the average of the y's. Very simple. I hope. So we use it. Let's find the midpoint of, oh look, it's the exact same 2 points. Gee, how about that? Let's just find the midpoint between these 2 points. Mr. M, are decimals okay? Yeah, so are fractions. I want you to start thinking fractions are my friend. They are not your enemy. Fractions are your friends. Decimals are not your friends. Fractions are your friends. I'm going to leave my answer in fraction form if it means a fraction. So the midpoint here, and you know what? And typically mathematicians put an M in front of it to represent that it's the midpoint. I don't care if you do or don't. I'm just letting you know. I'll go ahead and write it this time. First x plus the second x divided by 2, and the first x plus the second x divided by 2. 1 plus 6 is 7. I'm going to leave it as a fraction. 7 over 2. 3.5 is okay, but I like fractions. And 5 plus negative 1, that's the same thing as saying 5 minus 1. 4 over 2, which is just going to be 2. And there it is for that. I'm hoping that we're starting this year off nice and easy, and everybody's looking at this going, yeah, this class is easy so far. That's what I hope. Questions, comments, concerns before we move on to circles? No? Okay. Flip them. Now let's talk about circles. Equations of circles. By definition, a circle is the set of all points in a plane, x comma y plane, that are the same distance from a fixed point. Okay, well that fixed point would be known as the center. And that distance that we're talking about, that would be the radius. So the radius is the distance from the center of a circle to the edge of a circle. And the edge of that circle, literally the circle itself, is the set of every single point that is exactly the same distance from that center. Okay, let's go ahead and find the distance between 2 generic points. Now I called those points xy and hk. Instead of saying x1, y1, x2, y2. That way I don't have to use subscripts. You comfortable with that idea? That this is just a different xy and I just use different letters? Cool with that? Okay. Let's find the distance. Well, the distance between 2 points, which is on the other side of this page, is the square root of one of the x's minus the other quantity squared plus one of the y's minus the other y quantity squared. And we just said that that distance was the radius, right? So instead of saying d, I could say r. So r equals that square root stuff. And I hope nobody minds, but I don't feel like writing it all. So square root of some stuff. You're going to see that I do that kind of stuff a lot because it's just easier than writing it all over again. I understand what's going on. So yeah, all that stuff again is underneath that radical. And you know what? Gosh darn it, I just don't want to look at a radical. So how do I cancel the square root? You square both sides, yeah. So if we square both sides, what's going to happen here is that, you know what? Amazon Basics yellow. The radical will be canceled by the exponent, and what you are left with is the standard form equation of a circle with center hk and radius r. X minus h quantity squared plus y minus k quantity squared. Go home, k, you're drunk. Let me fix that. Equals r squared. That is the standard form of a circle. Ta-da. It's nothing but the Pythagorean theorem. It's the distance formula. It's crazy. It's all tied together. So you want to know where the center is? It's what makes the insides of those parentheses equal 0. You want to know what the radius is? It's the square root of this number. Done. That's it. We okay with how we got there? Everything's good about that? Okay. So what I have done here is just 2 examples. One of them says, write me the equation of the circle. And the other one says, here's the equation of a circle. Tell me some stuff about it. I need you to have both skills for your prereq test. So it says, hey, find the standard form of an equation with this center and this radius. So we just fill out the formula. x minus h. Well, h here is -4 and k is 1. So I'm going to be really careful. I'm going to say minus -4 quantity squared plus y minus k, which is 1, quantity squared, equals our radius, 8, quantity squared. You notice how I switched the color for things that I was substituting in. I like to do that so it's obvious that that was the change. That's where I used my knowledge of center and radius. I changed the color. That's why I went in color. And then we just simplify. Minus a negative, that means plus. There's nothing to do here except for write it in blue. And 8 squared is 64. That's it. That's the equation of the circle that has center -4, 1 and radius 8. Ta-da. And that's actually the harder question. The easier one is looking at the equation of a circle and just telling me what the center is and what the radius is. Switch over to purple. Ooh, looks like blue. On my paper, they look really different. Our center, it's not center equals, don't do that. It's like center colon, okay? It's going to be what makes the inside of the parentheses equal 0. That just means switch the sign. So what makes this equal 0? You can say it. 2. Yeah, because 2 minus 2 is 0. And what makes this equal 0? 5. Yeah, 5 minus 5 is 0. And your radius is just going to be the square root of this number, which is just going to be 2. Actually, no, this is radius equals. Radius equals 2. Because that number is 2 squared. I chose 4 for a reason. Because on the test, guess what one of the bad answers would be? Well, 2 is actually the right answer. 16 is one of the bad answers. See, I chose a number that was a perfect square. That way, I could check to see if my students know they're supposed to take the square root, not actually square the number. I don't believe in math surprises. I'll always tell you what kinds of things I will do wrong on purpose because my tests are multiple choice, multiple select, or fill in the blank. And a question like this, I'm pretty sure this question is multiple select on the test. I don't have a problem telling you that. It doesn't hurt my feelings at all. And one of the wrong answers would have been 16 for the radius. Of course, one of the wrong answers for the center would have been -2, -5. So just be really careful. Make sure you understand you're making the inside equal 0, and you're taking the square root of the right side of the equation. And that is it. And if the right side of the equation is not a perfect square, you just put a stinking root bar over it. Let's say c equals 5. Square root of 5 is the radius. And that's it. Feeling good? All right. Fantastic.